Alright, so this time I'm going to explain the electrical power supply system and how it plays into starting our APUs, because we have a few different ways that we can start the APU. We've got basically 1, 2, 3, 4 different ways. So this time, for the first shot, we're going to go with starting the APU with our with external power and 2 working batteries in the battery compartment. So we'll have a working battery over here in the battery bus, and we'll have a working APU battery here. And so normally with external power applied, our RTRUs will convert it to DC power. We'll end up with DC power making its way through here, down, through the de-energized contacts of our APU bus power select switch. Now you can look over here, I kind of got this from the dash one, but depending on our configuration will depend on how we have our switches placed. So right here, with external power on, APU batteries installed, 2 good working RTRUs, our APU battery charge switch, which is over here, will be in the on position, which it's already drawn that way. So then back over here to the APU control bus. So we got power, 28 volts DC powering our APU control bus, making its way over here, also powering our APU FDCU sub bus. Now, let's see. With that being done, our APU control bus will then power our FADEC, which our FADEC is kind of the brains of starting up our APU. So our FADEC has power down here. And let me trace out the rest of this power over here, that way you can see where it's coming from. So from our APU battery bus, our APU battery up here is sending power through, powering our APU battery bus, and from there our APU battery bus is sending power through, down here, basically to both our APUs, but we're just going to start this one up right here. And we have power sitting waiting. Now we talked about the power over here with the FADEC. Now it will, gotta get a smaller line because it gets really convoluted in here. So once we take our switch to start, then our FADEC will start sending power to both of our start relays in here. Over through, powering this relay, and then the FADEC will provide it a ground, which then, with that being done, it'll swap over our contacts here, which then will swap over our contacts here. 2 seconds later, the FADEC will then send power to the other relay, energizing it, providing it a ground, also then swapping our contacts here and swapping our contacts here. Then power is allowed to make its way all the way through, down, and over to start our APU. Let's see. Now when these contacts right here swapped, simultaneously, it happens really fast. They provided a ground. You can see the ground right there. And what that did is, if you trace this, let me change it to yellow so it's a little more distinguishable. If you trace this line out, and you keep tracing it up and through, out, it's basically going to provide a ground for this relay right here, internal to our beacon. And you can see here that our APU battery has power going to the beacon, to that side of the relay. So now this relay is going to be energized, swapping over these contacts here, which is then once again providing another ground. And if you trace the ground that is providing, it will make its way through, over, down, and then energize another relay. If you follow it through, basically it'll make its way all the way down to our APU control bus, is where the power is coming from, but the beacon basically provided a ground. Swapping over this contact here, and when that's done, it allows power to come from our RTRUs. So you can see here RTRU1, or this is number 2, but that way you can use that DC power being produced by the power cart, AC power from the power cart turned into DC through the RTRUs. And it kind of provides more of a muscle in starting an APU, because when you're starting the APU up, it creates kind of a pretty big draw. And so we have 2 RTRUs able to provide that extra muscle to start the APU. Alright, so that was starting the APU with 2 good batteries, 2 good RTRUs, and an external power card. This time, we're going to trace it out and see if we can get right here, let's see, external power on, APU batteries removed, 2 good RTRUs, and it tells us our switch has to be in bypass. So, let me go back to the other color. Okay, so this time, our APU battery charger switch has to be in the bypass position. And that kind of makes sense because we don't have an APU battery providing power. And so what we want to do is immediately provide a ground for our APU battery isolation relay, which will then close this contact right here. So if you trace it out, from our APU control bus right here, it gets the power all the way through, and it gets the ground because we took the switch to bypass. Now remember, our APU battery is out, so we have nothing coming from the APU battery. So with that being said, our APU control bus is getting power from our aircraft battery over here. So if you kind of trace it out here, all the way down, once again through the de-energized contacts of our APU bus select switch, we have power going to our APU control bus, making its way to our FDCU sub bus, and providing that power to energize the APU battery isolation relay. Now the rest of it is pretty much the same, because since we have power down here at our APU control bus, power can flow down all the way down to our FADEC. And when we take the switch to start, we're going to end up with the same process where the FADEC is going to, did the wrong line, but it's going to send power through, also providing a ground, energizing our relay, closing this contact. 2 seconds later, doing the exact same thing on the other side, closing this contact, which is providing 2 grounds right here. Now I can trace this all the way up. Basically it's going to go all the way to our FADEC, and I'll just kind of skip through that part. So it makes its way all the way up here to the FADEC, which normally would energize this relay here, pull these contacts right here, providing a ground all the way through and to our basically through the on contacts of our APU battery charger. But since we didn't have an APU battery and our APU battery bus wasn't being powered, nothing is going on there. So these contacts get swapped over through our RTRUs. We end up with power coming down here and through, coming down here, making its way down to start our APU. Okay, so that was starting with, what did we have? External power on, APU battery removed, 2 RTRUs, so we had to have the switch and bypass. So this time, let me clear all this out. We're going to do the external power on APU battery. Let's see, on APU batteries installed, 1 good RTRU, and so our switch, APU battery charge switch, has to be an off. So here, off, off. And so the reasoning behind that is because if we only have 1 good RTRU, so let's say RTRU number 2 is bad, the amount of draw coming from a single RTRU can make it fail. So same basic concepts, 2 good batteries this time. So we're going to have our APU battery coming down here, charging or powering our APU battery bus. And our APU battery bus is then sending power down and out this way. Okay, so then our battery bus is sending power down over through the de-energized contacts, and it's powering our APU control bus, and over here it's powering our APU FDCU sub bus. Since we have power at our APU control bus, the power will make its way down to the FADEC again, and when it does, we can take the switch to start. We'll have the same process. If you follow the lines up through, energizing the relay, which then will swap this contact, same thing on the other side, energizing the relay, swap this contact, providing the same grounds. And once again, to shorten this, if you follow it all the way up, it'll provide a ground for this relay here, and the relay is getting its power from the APU battery bus. The contact will swap within the beacon, providing this ground, but because we have our APU battery charge switch and off, if you follow this line out, basically it's not going to be able to go anywhere. It's not going to be able to energize our APU battery isolation contactor and use that extra muscle from our RTRU to start the APU. So basically all we have right now is our APU battery, sending power all the way down here through the contacts down to our APU to get it started. Alright, so that one was external power on, APU battery installed, 1 good RTRU. And so the last one that we can draw out is going to be the oddest to me. Whoops, wrong one. So this one's going to be, basically we have worst case, I guess really not worst case scenario, but just an odd scenario where we have only 1 good airplane battery in the aircraft. Then we don't have external power available to us. So what we're going to need to do at that point, let's say our APU battery just took a dump. Then we're going to have to take out our aircraft battery, and we're going to have to put it into the APU battery position. No, right here, sorry. APU battery position. And so then at that point, we no longer have a battery bus. And so under those conditions right here, so APU battery only, the APU bus power switch needs to be an alternate. So this switch right here, we're going to move it to alternate. And then our APU battery charger switch needs to be an off. It's going to go over here and be an off. And I mean, And as we talked about it before, this position being off will not allow our APU battery isolation contactor to close. And I'll still draw it out. But our APU battery then is sending our power down here, right, to our APU battery bus. Now, once we install this and our APU battery bus is powered, you can see if you follow this out here through the switch position that we made. At that point, we're energizing a relay. It has a ground, so the contacts here are going to be energized, and the contact's going to swap, which then allows power to go from our APU battery bus down to our APU control bus, also powering our APU FDCU sub bus. And if our APU control bus is powered, then we get power down to our FADEC. And if we have power down to our FADEC, we can go ahead and throw it in start. And so then, same process. These two relays, they'll get energized. Contacts will swap. 2 seconds later, a swap. The two grounds will be provided, and the power will come from our APU battery bus all the way down, come through, all the way down to our APU to get it started up. Now, once again, like I said, the ground is provided, but because if you trace this all the way up, over, up, same thing will happen. We'll get power from our APU battery to energize this relay. The ground's provided down here. The contact will swap over, providing a ground right here. And then, because we have our switch and off, basically the potential ground for our APU battery isolation contactor is not provided, so it will not close. That's all I got. Thanks for watching. Let me know what I messed up.